lesson, you should be able to find missing side lengths in similar figures using a proportion and use scale factors and ratios to describe relationships among the side lengths of similar figures. So what are similar figures? There are two figures that have the same shape, but maybe different sizes are rotated. And when two figures are similar, the ratios of their corresponding side lengths are equal. So in the two triangles below, 3 corresponds to 6, 5 corresponds to 10, and 7 corresponds to 14. So the ratios 3, 6, 5 over 10, and 7 over 14 all simplify to 1/2, making them equal. Since the ratios of corresponding side lengths in similar figures are equal, you can set up a proportion to find the missing side lengths. Since triangle A and B are similar, to find the value of x, we would set up the proportion 5 over x, since 5 and x are the two sides that correspond. That would be equal to 3 over 9, since 3 and 9 also correspond. Then to solve the proportion, 5 over x equals 3 over 9, you cross multiply. So you multiply 5 by 9 to get 45. Then divide by 3 to get 15. So x is equal to 15 inches. Pause the video and try this. Triangle A and B are similar, so 4 corresponds to 8 and 3 corresponds to x. So we would write the ratio 4 over 8 equals 3 over x. And to solve, you cross multiply. 3 times 8 is 24. And 24 divided by 4 is equal to 6. So x is equal to 6 centimeters. Now, when we look at the side lengths of the triangles, you may have also noticed that 8 is twice the length of 4. So 4 times 2 would give us 8, and 3 times 2 would give us 6. That means that triangle B is 2 times as large as triangle A. 2 is then the scale factor from triangle A to triangle B. Have you ever looked at tall objects such as trees and flagpoles and wondered how tall they were? Well, you can find the height of a very tall object using a ladder and long tape measure. But an easier, less dangerous alternative is to use similar triangles to estimate the heights. On a sunny day, any upright object casts a shadow. That shadow and the object form the legs of a right triangle that is similar to the right triangle formed by any other object and its shadow at that same time of day. So, for example, if you have a tree and a person, the height of the tree over the length of the tree shadow would be equal to the height of the person over the person's shadow length. You can set up the proportion as shown. Now we can use this proportion to solve for any missing side length. The height of the short object over the shadow of the short object would equal the height of the tall object over the shadow of the tall object. Pause the video and try this. The height of the windmill will be x, since that is what we didn't know. So then we set up our proportion, 56 over 84 inches equals x over 420. We're putting the height of the person and object over the length of their shadow. Once you set up the proportion, you cross multiply. 56 times 420 is 23,520. And divide that by 84 to get the height of the windmill. which is 280 inches. Tomorrow in class, you will be measuring your height, your shadow, and a tall object's shadow, and finding the height of the tall object using a proportion.